Okay, so, here goes nothing. We'll see how this goes. The first one I'm going to talk about is going to be quadratic formula. If you are in integrated 3, this is something that gets introduced in integrated 2, so it shouldn't be totally new, but it may have been a while. The first thing we're going to do is we're going to get it written down. So the key is we want to start with our quadratic equal to 0. Anytime we're trying to solve or get solutions, it's necessary that it equals 0 first. So if you have anything on the other side, just bring it on over. And once we do that, then we have the following. X is equal to the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And at the end of the day, you just kind of have to memorize it. There's no real shortcut or trick. Technically, it's found by completing the square, but your odds are that you're just going to remember it. And it's really not too bad to use, because all you end up doing is determining what your A, B, and C are and plug them in. So to get us started, we're going to look at 2 examples today. First one, example 1, is going to be x squared minus 5x minus 14 is equal to 0. We luck out, it's already equal to 0 on one side. So all we're going to do is find our A, B, and C. First up for A, the number in front of x squared. Anytime there's no number in front, that coefficient will just be a 1. Number in front of x, here's where you have to be careful. It includes the sign that's with it. So I'm going to say that that's equal to a -5. And then C, the value just by itself, that lone coefficient, will be equal to a -14. So all I'm going to do is I'm going to take those 3 values and I'm going to plug them into this equation. Following what I mentioned previously in class, even though it's a bit excessive, I'm going to go ahead and use all the parentheses. So I'm going to say x is equal to the opposite of b, which is a -5, plus or minus the square root, -5 squared, minus 4, a is 1, c is minus 14, I extend my square root a little bit, and it's all over 2 times my a value of 1. Now as you get more comfortable with these problems, if you want to start simplifying as you go for it. You know, a lot of times we'll just go and change the sign from the get-go. No worries if you want to do that, but for this first example I'm just kind of writing everything out. So as we continue down, minus a negative, that becomes a +5, plus or minus -5 squared would be a +25, minus 4 times a 14 is going to be 56. I'm going to have a minus 46 all over 2 times 1, which is a 2. Continuing it all down, if I have a minus, that's going to become plus a positive. So I'm now going to have, when I combine those terms, I'm now going to have 5 plus or minus the square root of 81 all over 2. This one actually works out quite nicely. I can break down the square root of 81. Number times itself that equals 81 is going to be 9. So I'm going to get 5 plus or minus 9 all over 2, which anytime I can combine terms and simplify, I should. So that means that I'm either going to have 5 plus 9 over 2, or I'm going to have 5 minus 9 over 2. 5 plus 9 is 14. 14 over 2 gives me 7. Or 5 minus 9 is a -4. -4 over 2 gives me a -2. And those are my 2 solutions. Depending, those are your roots. If they're written as x-intercepts, you might even see them written as 7, 0 and -2, 0. The fact that we got nice numbers like this means that this original problem did factor. Now if we didn't see that right away, that's okay. Quadratic formula is one of several strategies that we have, but that is an example of one that could factor. Right? So that's the first example. We'll go ahead and take a look at one more. I'm going to pause for a second. Make sure you've got that if you need it. And this one's going to give us a little bit of a trick as we finish. So, example 2, I'm going to have 8x squared plus 6x equals negative 5. Okay? So as a reminder, here's our quadratic formula over here. You can see our formula, and the first thing we need if we're going to use it has to be equal to 0. So the very first thing I'm going to do is I'm going to add this 5 to both sides. And so I end up with 8x squared plus 6x plus 5 equal to 0. And now that it's equal to 0, I can take advantage of the quadratic formula. So my a value is going to be 8, my b value is going to be 6, and my c value is going to be a positive 5, not a negative 5. Okay. Same as before, I'm just going to plug those three values in. So I'm going to have x is equal to the opposite of b, which is a positive 6, plus or minus the square root, b squared minus 4 times a times c, extend that root a little bit, all over 2 times a, which is 8. So again, a, b, and c, just plugging them straight into this formula over here, nothing too special. We'll start simplifying this on down. I'm going to get a negative 6 plus or minus square root of 36 minus 4 times 8 is 32. 32 times 5 gives me 160. All over 16. Right? And if we multiply that down, we now get the following. Negative 6 plus or minus square root of negative 124 over 16. Two things happen here. One, I got to deal with this negative sign. If you are in a class where negatives aren't allowed under square roots, maybe you're just getting started, it's possible that right away the answer is going to be no real solution. This is a correct answer. It's true, there is no real solution. However, we do have a way with dealing with those negatives under square roots. Specifically, anytime we see a negative under a square root, it comes out as I. So that square root of negative 124 is the same as just saying I square root of 124. Okay, that negative sign can come out. The other detail we have to be careful of, though, is that 124 can actually simplify. And to do that, we're going to come to the side and we're going to take a look at what can come out of the square root of 124. And the trick I like to use here is you want to pull out numbers that multiply together to make 124, and you're looking for pairs. So maybe you see pairs right away, maybe you don't, but you got to factor it down anyways. So just the first thing that comes to mind, and when I look at that, it's even, so I know I can pull a 2 out. If I pull a 2 out, then that means I'm going to have 62 left over. 2 times 62 is 124. 62 is even again, so I can pull a 2 out. I'm going to have a 31, and 31 doesn't break down anymore. And so what happens is, you can think about that square root as being jail. And if you're going to try to break out of jail, you need a buddy. And so when I look at this, that 2 has a buddy, which means that 124, the 2 is going to come out of the radical, but the 31 is stuck inside. So to put it all together, when I come back to this part right here, the square root of negative 124, I'm going to rewrite it as 2 root 31, and that negative sign is going to come out in front as an I. I'm now going to have an imaginary number. So putting that together, again, plus or minus, 2, pull out the I, root 31 all over 16. The 124 wrote down into 2 root 31 like we saw over here, and the negative sign inside came out as an I in my problem. The very last step before we finish up is we have to recognize that I can simplify. And here's what I want you to be careful about. You can only simplify if all three of these terms have a number in common. Number has to be outside of the square root, can't be inside of jail, and it has to be on all three spots. All three of these spots do have a 2 in common, so I'm going to cancel that 2, and I'm going to simplify this down to negative 3 plus or minus I. Oops. So negative 3 plus or minus I root 31 all over 8. And that is going to be my final answer. Right? As a comment over here, suppose I gave you the following problem and you did some work. Put a note. Suppose you did some work and you got this over here. Negative 6 plus or minus 2 I root 30 all over 3. Yeah, the 3 cancels with the 6. Yes, the 3 cancels with the 30, but I can't cross any one of those pairs out. And there's no 3 to cancel with this top part in here, because the 3 doesn't go inside a jail, it stays outside. So because of that, this would be my final solution. There's no more simplifying I could do to this problem. If I want to simplify over a plus and minus, it has to be in all 3 parts of my fraction, like it was right there. So hopefully that helps you out. You got 2 good examples to take a look at. Please take a look at the worksheet online. Try a couple more on your own, check your answers, see if you're getting the right thing.